Now, in question number 4, there seems to be a problem. If you notice, there's a 1/2. If I distribute that 1/2 right here, then I get 1/2 times 5, and that would give me 5 halves. But to be quite honest, I don't want to deal with fractions. So one of the methods that you can incorporate is this. Anytime you want to get rid of fractions, what you can do is you can multiply every term by the denominator or by a common denominator. So for instance, since 2 is my only denominator, this is a multiplication right here. So if I multiply this side by 2, that means I can multiply this side by 2. And look what happens when you do this. The 2's cancel out. You're left with 5 minus 2x is greater than. In this side, you have to distribute the 2. Minus 2x plus 2. And as you notice, there are no more fractions. So that's one method in order to get rid of the fractions. And then simply, we just, like on here, I'm going to add the 2x, add the 2x. And then when I eliminate these, I bring down the 5, greater than, the 2x's are gone, bring down the 2. Now, I'm left with 5 is greater than 2. Well, there are no more variables. All my variables have canceled out. Now, that is okay. So when is 5 ever greater than 2? Well, all the time. So therefore, it would be infinite solutions. So any number you pick will be able to support that answer. All right? Now, let's go to the next problem. Same scenario with this problem. Notice I have a denominator of 3. Well, if I take my equation, all right, now if you notice, it's pretty much the same. So one of the things I'm going to do is I'm going to get rid of the denominator of 3. Well, I'm going to multiply everything by 3. That means this gets multiplied by 3, that gets multiplied by 3, this term, and this term. So I have to distribute to all of them. Okay? So notice 3's cancel out. I'm left with 2y. Plus 6 times 3 is 18. 3's cancel out. I'm left with 2y. And then 6 times 3 is 18. Now, I have to go through my steps. I'm going to add 18 to both sides. So that's gone. This, I'm left with 2y plus 36 is less than 2y because 18 and a negative 18 cancel out to 0. I'm then going to subtract 2y from both sides. Now, you've got to be careful here. When I subtract the 2y's, that leaves me with 36 is less than, now 2y minus 2y is 0. So when is 36 less than 0? Never. So this is no solutions. Okay, now in this particular problem, you have to pay attention to the table. Notice these are in decades, so 1980 to 1990, and this is asking for each year. Okay, so make sure you pay attention to that. Let me go ahead and right here again, each year. All right. About how much did the population of Toledo change each year? Well, if you notice, Toledo goes from 350,000 to 330,000 to 310,000. It's decreasing by 20,000 every decade. So if you do 20,000 divided by 10, that gives me, it decreases 2,000 each year. So what I want you to write is this. Let me go ahead and erase that. So what you want to write down is it decreased 2,000 people each year. All right, each year. Now, write an expression for the population of Toledo. Well, in this case, what I want to do is I could simply say that I'm going to start off with 350, so 350,000, and we're decreasing by 2,000 people each year. And that's the expression I could use. Now that I've shown you how to do Toledo, try Lexington. Notice that Lexington is increasing by 30,000 each decade. Therefore, so 30,000 each decade, so I'm eliminating a zero, so that means it's 3,000 every year. So in this case, we're going to say it So we're going to say that it's increasing by 3,000 people each year. All right, that's supposed to be in. So increasing by 3,000 people each year. Then it says write an expression. Well, that expression would be, we're going to start off with 200,000 people, and we're going to add 3,000 people each year. Now, the last thing is we need to find the years in which the population of Lexington will be greater than Toledo. So that means Lexington has to be greater than Toledo. Here's Lexington, here's Toledo. So we're going to take both of those expressions. I'm going to minimize this a little bit, okay? And then I'm going to put this right here. So here's Lexington has to be greater than Toledo. So Lexington is 200,000 people plus 3,000 per year. And it's got to be greater than Toledo, which is 350,000. Oops. One little extra zero. Minus 2,000 per year. Now I'm going to solve it. So in this case, I'm going to do my variables first. So I'm going to add 2,000 to both sides. That cancels that out. I'm left with 350,000. And this is 200,000 plus 5,000y. I'm going to subtract the 200,000. That gives me 5,000y is greater than 150,000. Now, I'm going to minimize that a little bit so I have more room to work. Let me move this out of the way. All right, so now I'm simply going to divide both sides by 5,000. Years is greater than, well, let's mark out some zeros there. 150 divided by 5 is 30. So in 30 years, so basically the 31st year, Lexington will have more than Toledo.